Okay, so yes, can you go to the next slide, please, where we can see the scope of what we are doing at Northern Lights. So Northern Lights, it's a first in the world. We are the first project to propose transportation and permanent storage services for CO2. We are part of a bigger project called Longship, which include also the capture part of this project. This project has been launched in 2017 and it's subsidized by the Norwegian government for its first phase. It consists of 2 capture sites in Norway, 1 cement factory and 1 waste to energy plant. That will capture their CO2, and Northern Lights is coming with this vessel, picking up the CO2 at the emitter sites, bringing it to the receiving terminal that is based near Bergen in Norway. And then we send the CO2 offshore for storage in a saline aquifer. So here you see the schematic of this project. Very quickly on the project, we are now on the construction phase. If you go to the next slide, you will see the progress of this. The idea is that we start receiving CO2 in 2024 from the cement plant, and then the waste incinerator will come a bit later. You see the jetty here in this photo that will accommodate for the vessel, as well as the temporary storage site. And here you can see the basis for the storage tank that we will install later this year. If you go to the next slide, you will see also that we have already drilled 2 wells offshore Norway. So those 2 wells will give us the possibility to inject 1.5 million tons of CO2 per annum in the storage complex. We have drilled 2 wells because one is a main injection well, and the other we call it the backup well, in case we have we need for a contingency solution. So that's the first phase of the project. And the second phase will be started later this year, where we will increase our capacity from 1.5 million tons to 5 million tons. So we have confirmed the capacity of this 5 million tons per annum when we have drilled the second well, and we will start the construction or the extension of the facilities later next year. So a word on our service and the market we are targeting. If you go to the next slide. So we are a European project, although of course the storage capacity can store CO2 from everywhere in the world. It doesn't make sense economically to pick up CO2 too far from our storage site. So we are basically aiming to address the need of Northern European emitters. We have seen a significant interest in demand in our services, and we have signed a first commercial agreement with a fertilizer plant of Yara. Yara is a leader in the fertilizer production, and they have a plant in Sluiskil in the Netherlands, where we will pick up 0.8 million tons of CO2 per annum to store it in our storage complex. We are the first, and we are paving the way for the others. And being the first means that we have to face some challenges, mainly linked to the fact that it's a new services. So there is a lot of question around risk sharing between emitters and transportation and storage service provider. There is a lot of question of liabilities. and risk transfer, tighter transfer of the CO2, and the regulatory framework is still adjusting to this risk sharing mechanism. So we are actually building this framework as progressing in the commercial discussion. There is also a need for a discussion between countries in order to be able to export CO2 from one country to another. We need bilateral agreements between countries. So we are also, this is a challenge. We have been involved with several ministries in Norway, of course, and in the country of our customer to address the need for these bilateral agreements. Next slide, please. So this is the industries we are addressing with our services. So more than 300 million tons per annum of CO2 is emitted and needs to be or potentially needs to be stored in Europe. So if you compare to the 1.5 we are proposing right now, it's not so much. But you need to start somewhere, and mainly what we are addressing is cement and waste, as I mentioned. Those are the two first customers, and the third one will be the fertilizer Yara, which is basically an ammonia production plant. But it's not only to this R2H8 sector that we are discussing with. We are also proposing a service to companies that would like to create carbon removals, and this is linked to obviously bioenergy with CCS project and direct air capture project. Next slide, please. As I mentioned already, we are a regional solution. We think that our model is replicable around the world, but obviously the shipping, using shipping as to address the transport and the transportation need of the CO2 has its limitation. It's flexible because you can go everywhere, and you see in this graph that we have discussion up to with emitter up to the Baltics and also up to northern of France. But it needs to be a regional solution for now. So we are active in the discussion with European emitter and also with the European Commission and policymaker, trying to see how we can have this European framework. Now I would like to discuss more about what is the role of Northern Lights in the CCS Plus and why we believe this is an enabler for the negative emission. If you go to the next slide. So this is the schematic to show what are the leverage we can do for the CO2 cost. This is really based on emission reduction and rather than carbon removal. Emission reduction, we have a cost that can come up to 250 euro per ton. If you see that, roughly half transportation and storage, and the other half is capture. We have this carbon tax, the ETS, in Europe. And we have a lot of subsidies coming, trying to lower down this cost, to increase the affordability of this service. But obviously, we need national complement in a way of additional subsidy or carbon tax. In Norway, for example, the first CO2 storage project started 25 years ago in an oil and gas facilities, and it was driven by the fact that the Norwegian government put a tax on CO2 emission for oil and gas facilities of nearly 200 euro. So they had to develop this. And today we can actually use all the knowledge that have been developed in this CO2 injection technology in saline aquifer to develop our project. So this is really needed, national complement. And then you have what we have, net to industry. And the link with the CDR here, it's that for CDR, especially in Europe, so carbon removal in Europe, the ETS leverage cannot be used in a way because biogenic CO2 is not subject to ETS. So we need additional leverage to be able to make this technology affordable, and this is where we need the carbon market. So if you go to the next slide. So that's what we are trying to do, trying to set up an enabler for negative emission in Europe. And we believe, and this has been highlighted by Christian earlier today, we believe that providing a transparent and reliable methodology and framework is very important to be able to attract this income stream. Next slide. So this is the overarching of the CCS plus methodology. So Vera will provide the standard, as you know, and the methodology is going to be developed by the CCS plus initiative. And we at Northern Lights, we are developing a project documentation to apply the methodology and to show that it's possible and it's feasible to apply this methodology right away. So we have launched our project earlier this year. We have decided to use a bioenergy with CCS project to apply the methodology and to develop the project documentation based on the methodology. And this is also preparing or paving the way for the EU certification for carbon removal that is going to be in place probably in 1 or 2 years from now. Next slide. Just to show you some example of the specificities of this methodology. The first very important item is the differentiation between the CO2 from reduction and removal. Because we at Northern Lights are providing this service to both customers, emitters that have fossil fuel originated CO2 and emitters that have biogenic CO2. So we need to make sure that from the capture up to the final storage, we are differentiating the flow of the biogenic CO2 and the fossil fuel CO2. So this is what we are doing in the process operational manual that we are developing for the project. If you go to the next slide, you can also see a schematic of how we are going to measure the flow. Next slide, please. Yes, this one, quantity measurement philosophy. So here you see that at several points of the value chain, we will have level measurement and rate measurement. So that's the beauty of using a CO2 molecule of CO2 that we can actually count. We have available technology to be able to count the CO2, the flow of the CO2, and how it goes in and out of the storage tank. So each time there is a transfer from one point, from one facilities to another, we are going to measure the CO2 and we are going to register this flow. And this is coming from the capture part up to, as you can see, up to the injection into the storage tank. So the CO2 we are transporting and storing is nearly 100% pure CO2. this is a very important requirement that we have discussed also with our customer. We have nearly no impurity in this CO2. It's a pure CO2 that we are going to store. So that's to show you how it works across the value chain. Then if you go to the next slide, you will see what we are going to do for the storage monitoring. So once the CO2 is inside the storage complex, the geological storage, we have, and this is one of the core competencies of Northern Lights, we have developed a modeling of the storage complex that is including all the geological characteristic, geochemical, geophysical characteristic of the storage, and we can model how the CO2 is going to behave in this storage. So the idea is that we need to compare regularly how the CO2 is behaving in the storage comparing to what we have modeled. And for that, we are going to do several monitoring and seismic around the storage, around the life of the storage, so we can make sure that the CO2 stay in place. We can track if there is any migration of the CO2, and we can also detect if we feel any leakage of this CO2 has happened. We have a commitment to use the best available technology to always update our model, and this is normal because when you look at the timeline of this project, if you look at this timeline that you see on this slide, we are going to inject for 25 years. So this is the operation part of our project. But once we close this, once we close our reservoir, we are going to monitor 20 years additional on top of these 25 years to make sure the CO2 stays in place. And when we have proven the CO2 is in place and not moving, then we can transfer to the government saying that, okay, this is not going to move, it's going to stay here for millions of years. And this is a proof of that. Next slide, very quickly, you will see how does it look. This is based on the CO2 injection that is happening in Norway, as I mentioned at the beginning. So you have here what is happening before. You don't see any CO2, and when we do seismic data, we can see the CO2 is injected, and we can also track what's the behavior of the CO2 in this in the geological storage. So the next slide is my last slide, is just to put back here what are the challenges we are facing again, and we believe that explaining what we are doing and make sure that we are using a very high environmental integrity process and methodology to prove that the CO2 is permanently stored is one of the key to enable the scale up and also the growth of the CCS industry. Thank you.
Thank you very much, Elise, for your wonderful presentation. Well, surely Northern Lights is the lighthouse project involving a new business model which utilizes voluntary carbon credits and demonstrate the capability of CCS carbon credits. I hope we can learn the lessons from Northern Lights project and accelerate CCS deployment in Asia. Thank you very much, Elise, for joining us today.